sklearnmetricsaccuracy score. Description: accuracy score is a metric used to evaluate the performance of a classification model. It is defined as the ratio of correctly classified instances to the total number of instances. Accuracy score is a simple and commonly used metric, but it can be misleading in some scenarios, such as when the dataset has an imbalanced class distribution. Inputs: y true, the true labels of the data. Typically a 1D array of integers representing the class labels. Ypred, the predicted labels by the classification model. Also a 1D array of integers. Outputs: accuracy, a single floating point number representing the accuracy score, ranging from 0.0 to 1.0, where 1.0 indicates perfect accuracy. Steps: the function compares the predicted labels Ypred with the true labels Ytrue for each data instance. It counts the number of correctly classified instances. It divides the number of correctly classified instances by the total number of instances to compute the accuracy score. Metrics: accuracy, the primary metric calculated by this function, representing the proportion of correctly classified instances. Visualization plots: confusion matrix, a visual representation of the classification results, showing the number of true positives, true negatives, false positives, and false negatives. ROC curve, a plot that shows the trade-off between the true positive rate sensitivity and false positive rate 1 specificity at different classification thresholds. Fine-tune parameters: normalize, a Boolean parameter default true that determines whether to normalize the accuracy score by dividing by the total number of samples. If set to false, the raw count of correctly classified instances is returned. Uncertainty methods: confidence intervals. Confidence intervals for the accuracy score can be calculated to quantify the uncertainty in the estimate. Challenges and fixes. Challenge 1: imbalanced class distribution, when the dataset has a highly imbalanced class distribution. Accuracy score can be misleading. For example, a model that always predicts the majority class might achieve high accuracy but have poor performance on the minority class. Sample use case that resulted in challenge 1: a dataset with 90 positive samples and 10 negative samples. A model that always predicts positive achieves an accuracy of 90 but fails to detect negative instances. Fixes to challenge 1: use more appropriate metrics like precision recall, F1 score, or AUC ROC. Consider using techniques like oversampling or undersampling to balance the class distribution. Challenge 2: mismatched data sizes. If the sizes of the true labels Ytrue and predicted labels Ypred do not match, the function will raise an error. Sample use case that resulted in challenge 2: Ytrue has 100 instances, while Ypred has 101 instances. Fixes to challenge 2: ensure that the sizes of the true and predicted labels are equal before calling the function. You can use data manipulation techniques like padding or truncation to align the sizes.